Access Minnesota. Issues that matter to you. Access Minnesota brings you the newsmakers and the stories that shape our everyday lives, with analysis from University of Minnesota faculty experts. Now, here's Jim Dubois.
In 2016, the University of Minnesota Extension Program selected 5 regions in Greater Minnesota for a deep winter greenhouse, or DWG, research project. Designed for small-scale farmers to grow crops year-round, the DWGs use solar energy to limit the amount of fossil fuel normally required to grow crops in northern winter climates. This month on Access Minnesota, we talk with the 2 University of Minnesota researchers who are spearheading the project. Greg Schweizer is the Associate Director for Sustainable Local Foods for the Regional Sustainable Development Partnerships that's part of the University of Minnesota's Extension. Dan Handeen is a research fellow in the University of Minnesota's Center for Sustainable Building Research, and he designed the prototype for the U's Deep Winter Greenhouse. Welcome to Access Minnesota.
Thanks.
We're talking about the University of Minnesota Extension's statewide campaign to build 5 prototype deep winter greenhouses, or DWGs as they're called. Let's talk about what exactly a DWG is. Most people are probably familiar with the typical greenhouse. How are the DWGs fundamentally different?
Dan, as the designer of the prototype, might know a little bit more about this, but I'll take a stab at it myself. So typical greenhouses, they're controlled environments, and they're used to produce horticultural crops mostly. So as controlled environments, they're able to maintain a really constant temperature. So, depending on what they're growing. So they'll go from, 55 degrees to 80 degrees and day and night and day and night and day and night. These deep winter greenhouses are a little designed for a little bit of a different purpose. It's to help producers, farmers grow a winter crop, which is typically Asian greens, lettuces, cole crops like broccoli, cabbages, those kinds of things that can thrive in low temperature and low light situations. And so the design, which Dan will get into later, utilizes a south-facing glazing angle that can capture the sun's light and heat and store it in an underground rock bed. And so that heat from the rock bed dissipates into the ambient space at nighttime, creating just enough heat for those low light, low temperature plants to thrive.
I think a couple of the major differences, one is that we're really trying to tailor the production in this greenhouse for the deep winter, right? So we're looking at a period from November through March. Whereas most greenhouses typically you'd probably see growth, for horticultural production in, the shoulder seasons, spring and fall, or doing season extension. But this one really is designed for that, the deepest, darkest, coldest months, with the added layers of trying to reduce our fuel consumption as much as possible. Because, you could keep any greenhouse at 85, you could be growing bananas if you had enough light, if you threw enough fuel at it, right? Enough heat at it. The strategy with this is really trying to reduce the fuel consumption as much as possible by capturing that passive solar gain.
And Dan, how did you come up with the design for the DWGs? I imagine you encountered quite a few obstacles along the way.
One of the things that I constantly had in the back of my mind was trying to make this as simple as possible. So really stripping it back down to the basic passive solar design principles, but that with the added input of all these existing greenhouse operators and what they were doing in their greenhouses, what worked, what didn't, where areas of concern might be in relation to their structure and energy efficiency. So those were the overlays. I was adapting each of their designs really to come up with this prototype, and for me, it was this balance between performance, durability, and cost. Like making sure that it's keeping the heat in, that it's airtight, that we can build it, conceivably. Anybody could look at this set of plans. It doesn't take a specialized, profession or something to be able to build this thing. Pretty much any contractor should be able to build it. The materials pretty much available at your big box builder supply warehouse, with the exception of a couple materials, obviously for like the glazing and so forth. Then balancing that with the cost. Well, this is a little scale model of the deep winter greenhouse. This was built by David Flugel, who is the director of the Southwest Regional Partnership. And this is meant to describe the fundamental components of the deep winter greenhouse. So the biggest things that make this, as we're defining a deep winter greenhouse, is the glazing wall that has a steep slope. In the actual greenhouses, the prototypes that are being built, this will be slightly steeper so that we're catching more of the direct incidental solar rays as they come in the deep winter when the sun is lower in the sky. The way it basically works is that the sun shines through the glazing wall, heats up the air inside, and that air rises to the top, and there's a couple ducts or tubes that capture that heated air at the top and the peak, and then a fan draws it down. In this model, you can see, it draws the hot air down into these tubes, which then go down into the thermal mass. In this particular model, it shows a duct distribution within the thermal mass. For our particular prototype, we've moved away from this in the interest of simplicity, but this is a very common approach. I've seen this many, many times in many greenhouses. The hot air then circulates through this, heats it all up. You'll notice that this is insulated around the outside, around the perimeter, so that we're not losing heat to the surrounding soil. And then in the nighttime, or whenever it's too cloudy, the heated air is then either drawn back up into the space, into the growing area, or it gradually just rises back up into the space, heats the floor, or heats the beds in this particular case. In the back here, I think David has modeled a couple rain barrels or water storage barrels. This is another way of storing heat, essentially. Water storage has been a technique that's been used for centuries, and basically it's the same type of idea. The sun heats up these barrels of water back here, and they heat up during the daytime, and then they gradually re-radiate that heat back into the space at night.
When Access Minnesota returns, more about the Deep Winter Greenhouse Project and what researchers from the University of Minnesota expect to learn from the 5 prototypes across the state.
Access Minnesota will return after these messages. You're watching Access Minnesota. Here's Jim Dubois.
Now back to our conversation about deep winter greenhouses, or DWGs. In 2016, 5 partners were chosen for the Deep Winter Greenhouses, the research project, one for each of the regional Sustainable Development Partnerships regions in Greater Minnesota. The U of M's DWG projects include Bemidji Community Food Shelf, Central Lakes College in Brainerd, Organic Consumers Association in Finland, Alternative Roots Farm in Madelia, and Lake City Catholic Workers Farm. How did these sites get chosen for this project?
Well, we wanted to have 5, we wanted one site in each of our regions, and we wanted to find a balance between community organizations and producers and farmer producers. And so the 2 in the south are active farms. The ones in the north, the Bemidji, Brainerd, and Finland are all community organizations. We were looking for groups that could have that could provide access to the public, people who would, groups and people, meaning farmers, that would be willing to allow people to come visit their land, visit their farms, visit their greenhouse, would be willing to allow us to do research inside and have workshops, host workshops and open houses. And we were looking for people that had a lot of experience growing horticultural crops so that we knew that they'd be able to produce inside these greenhouses and be able to sort of take the concept and run with it. And we were just looking for that wide access, public access. That's one of the things we want to do with this project, is put these things on the landscape, these prototypes, and allow the public to come and kick the tires and sort of see what they look like, see how they work. Because, over the past 6-7 years or so, we've been doing a lot of deep winter greenhouse workshops, and people who are producing have been getting around, but there hasn't been a broad distribution of these things around the landscape. So this project enables people to come see one. They don't have to travel very far. They can see one in action, see how it works, talk to the producer, talk to the grower and owner, and help them make their decision whether or not they're going to build their own.
How did the construction process go at these various sites, and are crops actually being grown at some of the locations now?
Well, we only have one up so far because of a number of delays, mostly related to each of the partners. only the one in Finland, Minnesota. Started construction in October, and it's almost done right now. They're just putting the finishing touches on. They haven't been growing in the greenhouse yet. Obviously, they haven't had the chance to really bank the solar heat as you would anticipate a greenhouse in normal operation, or a deep winter greenhouse in normal operation would have at this point. So they've started seeds, but not in the greenhouse actually, as they're finishing things up in there. The remaining 4 will start construction in the spring and should be up for operation by next growing season, next winter.
Yeah, initially we wanted to build 2 this year and 3 next year. I think it's going to turn out for the better though, because there were a lot of little lessons learned here and there in the process with Finland. So we can take those already. Those have helped you update the design and the materials list. So all that stuff will be ready next year when we go out and do this 4 times again.
It really reinforces that the fact this is a collaborative effort between the university and our partners out there, the people who are doing the work, that are doing the growing, that are building the thing. And it's an exchange of information. So that's been a great part of the experience so far.
What do you hope to learn from the greenhouses?
Yeah, so one of the things I'm really curious about is how we can maximize production inside of these greenhouses. So right now there are, of the people we know who are producing in there, some of them are die-hard producers. They're doing it for their job, their living, and some of them are educational facilities, some of them are hobbyists. So we kind of have this hodgepodge of different information. It's hard for us to really get a sense of what's possible inside of these. We know that we can produce inside, we know that we can produce a lot, but how do we maximize production? How do we look at issues like our changing climate? It's getting cloudier in the winter here. That didn't used to happen. So how are we going to be able to tailor these so that we can add a little bits of light, just the right amount of LEDs or other lights to make production, to bump production to even allow us to produce more? And ultimately, how is this going to fit into a whole farm system? So how are farmers going to be able to take this system and add it to things they're already doing to become more profitable? Because one of the main benefits that we see in this system is it gives farmers the opportunity to produce a crop in a time where they currently don't have that capacity if they're doing crops and not livestock. This will help all farmers who adopt this hopefully do much better for themselves and to become more viable and stronger businesses.
How do you decide which crops to grow at a particular site?
The people who've been doing this over the past 10 years have taught us a lot, and we're working with them consistently. We're the workshops we do, we bring producers to teach those workshops who have been doing this a long time. They already have this sort of nailed down to an exact science. Those crops I mentioned earlier, those cole crops, those brassicas, they grow really well in these conditions because they like those conditions where it's 40 degrees or 45 degrees. It helps them put more sugars into their tissues, and they can tolerate those low light conditions. So the producers who have been doing this already know what crops grow best. There's certainly room to experiment. We have a hort professor on campus here who wants to simulate a deep winter greenhouse environment and grow 250 different varieties of a lot of these different things to nail down exactly which ones grow better. And there's a lot of room for that and room for improvement, but people who have been doing this for a long time already kind of know what grows well. A lot of things that you might think of when you think of greenhouse, like tomatoes, cucumbers, fruiting crops like strawberries, aren't necessarily going to do well in these environments because they're not controlled. They get too cold, and a lot of those crops need consistent heat, and they need a lot more sun than we'll get in these greenhouses right now.
How likely will deep winter greenhouses become a part of Minnesota's agricultural output? We'll talk about the prospects for DWG farming when Access Minnesota returns.
Access Minnesota will return after these messages. You're watching Access Minnesota. Here's Jim Dubois.
Now more on the University of Minnesota's project involving deep winter greenhouses in Greater Minnesota. The U's project is focusing right now on Greater Minnesota, but do you see DWGs as benefiting smaller, more rural communities at this point, or do you feel that DWGs will eventually benefit growers in urban communities as well?
It's tricky in urban communities. There's a lot of different issues that aren't really necessarily related to the greenhouse design. There's zoning issues, there's smaller lots, there's solar access. One of the things we realize with these, in the winter months, the sun is really low on the horizon. So here's your Earth, your sun is here, right? But in July, it's up here. So if you have trees way out there on the horizon or buildings or obstructions, it doesn't allow enough. It's potentially, depending on where your site, you might not get enough solar access. One of the things we found, though, is digging that 4-foot pit to put your rocks in. If you're in a city, you have a lot of dirt you have to figure out what to do with. And, you know, that could be a barrier for some people. And also there are power lines, all sorts of things. There are different barriers in the city. It can be done. People have done it. It's just you'll have to really work closely with your planning and zoning board and make sure that everything works.
However, we do see more and more support for greenhouse and locally produced agriculture in, well, the city of Minneapolis anyway, I know. And the scale of these greenhouses is such that you could put it in your backyard. If you did have enough solar access, you know, anybody could put this up. There are variations on the design so that you wouldn't necessarily have to excavate a pit for the thermal mass. And there's one farm doing a CSA, and they also produce for some wholesale for, you know, the local grocery stores and so forth, that has a variation on this design. They're operating out of their backyard, literally. And what I like about this is that it's such that you could conceivably have these, you know, sporadically placed around, you know, even an urban area to be able to provide for these local food sheds, if you will, you know, to be able to provide for a specific area. Not necessarily that it all has to be this massive scale of operation out in the suburbs or something that then gets trucked into the city, but it could really be these locally produced sources of winter greens, essentially. That said, we do see just a huge growth in controlled environment agriculture. I know around Chicago currently, there are a number of very large-scale operations. They're not relying so much on the passive solar aspects that we're focusing on for this project. We're, again, really trying to reduce our finite fuel consumption, our fossil fuel consumption. And these other controlled environment operations are looking more at, you know, LED lightings, supplementary heat, and they're not as concerned about the energy stuff, but massive scale, and they're, you know, they're still locally produced right outside.
Yep. There's a lot of good ones right here in Minneapolis too. So, yeah.
Do you think deep winter greenhouses will become a necessary component in the future of Minnesota's agriculture?
There's so much potential in these, if both at the scale where we're working at and a larger industrial, like sort of commercial scale, that if this works, which if it continues to work as it's working, so I don't have any doubts about that. I feel like that winter production could be a better fit for a lot of the farmers out there doing CSA right now with crop storage, meat and dairy issues, products, and deep winter greenhouse, like these types of greenhouses. I think winter production could be a serious possibility and a seriously profitable possibility, both at that small scale and at a large scale in Minnesota. So yes, definitely.
The other nice thing is that it really keeps our economies local. So instead of importing, you know, our whatever produce we're getting from California, say, we're, you know, supporting our local growers. We're keeping the money within our communities, within the state, and it's also giving us more assurance of a reliable food production system. There's a certain vulnerability to getting all of our salad greens from California. You know, say they have a massive drought. Who knew, right? So being able to produce that stuff locally really gives us some redundancy, right? We're being able to provide for ourselves locally. I think.
Certainly.
Is there a practical limitation to the size of the DWGs? At what point does the construction cost, the maintenance, become prohibitive and cut into any potential profit margin the producer might experience?
That's a good question, and those are a couple questions that we'll be asking based on these current 5 prototypes. Again, these are prototypes. These are really a proof of concept design, testing a number of different variables that, you know, are included in this design versus what's already out there. And so, you know, my perspective on it is really around the energy consumption, energy efficiency, and there's others focusing more on the economic aspects, as far as being able, what you can produce out of there. That said, looking forward from this, what we learned from this research, this particular project around what we're calling the DWG V 2.0, we'll take that information and develop V 3.0. And I think there is really another type of construction that can be more scalable, that's not as much of a capital investment, upfront investment, probably not as long-lived structure, but something that would be, maybe of comparable initial expense, but you could produce much more out of it.
Are you aware of any similar initiatives elsewhere in the world? And if so, how has that been going?
All over the world, literally. The original concept for this type of greenhouse, which is basically using passive solar design and then storing some of the heat, originated in China. Massive, acres upon acres upon acres under this type of greenhouse. Granted, the latitudes at which they're working are a little bit more moderate than we have here in Minnesota, so we've done a number of variations to make it work here. But I know of operations in Manitoba. I just got contacted by somebody up in the Yukon, just south of the Arctic Circle, that has a number of these designs, and we're looking at collaborating on another one in the future. Colorado has a number. North Dakota, I think we're up to around 27, something like that in the upper Midwest. That's Minnesota, and then the eastern edge of Washington. I know of one in North Carolina. I know of one in Oklahoma. The thing about these, they're all operating. They're really, I think the momentum is growing, really, around knowledge of this type of approach, of this concept. So we see more and more people doing it. But I think it's still isolated knowledge. It's kind of anecdotal. This person will put together their own report on it, and this grower will put together their own report. And then there's a lot of people that they're just doing it on their own. They're not in it to try and educate necessarily. They just want to grow stuff in the winter, whether it's for their family or for a business or something like that. But they're everywhere, and that's one thing that I don't think we fully realized when we first started getting into the project. We were like, oh, this is a great idea. There's a number of people doing this in Minnesota, and I think at that time there was probably 5 structures, something like that. And we're like, well, we'll research this a little bit further and try and optimize the design. And since then, it's blossomed even in Minnesota since the start of our project. And we started doing research about all the other projects around the nation, really around the world, and seeing how many there are.
Greg, Dan, thanks so much for joining us on Access Minnesota.
Well, thanks.
Thanks for having us.
Mm-hmm.
If you're interested in finding out more about the U of M's deep winter greenhouses, go to the University of Minnesota's Extension website. Or if you'd like to attend a public open house, the Northeast Regional Sustainable Development Partnership will be showcasing a DWG in Finland, Minnesota on February 18th. That's all for this month's edition of Access Minnesota. We'll see you again next month. Thanks for watching.
Access Minnesota. Issues that matter to you. Join us again next week as we bring you the newsmakers and stories that shape our everyday lives. Access Minnesota is produced by the Minnesota Broadcasters Association in cooperation with the University of Minnesota's College of Liberal Arts.